The fabric of spacetime might soon fail to keep up, leading to a catastrophic rift. This alarming thought haunts me as the night sky undergoes swift changes, and within just a few decades, or perhaps even years, it could look completely different. Astronomers across the globe are raising the alarm. Leading experts, such as Neil deGrasse Tyson, have recently confirmed the upcoming detonation of Polaris, and the aftermath behind it is quite unsettling. Polaris, the North Star, has long been a steadfast fixture in our night sky, acting as a vital reference for stargazers, explorers, and scientists. However, this constant might soon be disrupted, changing our view of the sky and our astronomical measurements forever. Let's explore the significance of this impending threat and its impact on all of us. Join us as we uncover the tale of Polaris as it nears its end. For centuries, Polaris has been a guiding beacon for sailors and astronomers alike, occupying a cherished place as a celestial marker. Its unyielding position in the sky has been essential for navigation, but this stability might soon be upended. In September 2023, a research paper released by the prestigious Royal Astronomical Society cast doubt on the fate of this stellar icon. Polaris is on the verge of detonating, possibly vanishing from the night sky forever. Before we dive into the implications of this finding, let's better understand the significance of Polaris, also known as the North Star or Pole Star. Polaris is remarkable because of its close alignment with the celestial North Pole. Positioned almost directly above Earth's northern pole, it appears almost motionless in the northern sky. Located in the constellation Ursa Minor or the Little Dipper, Polaris shines as a moderately bright yellow-white supergiant, much larger and more luminous than our Sun. However, it is not a lone star. It's part of a complex triple star system with Polaris A and Polaris B forming a binary pair, while Polaris B orbits around them. The gravitational interactions between these stars shape their orbits and influence their behavior. Disruptions in these interactions can cause fluctuations in the star's brightness or pulsation patterns. However, the exact reasons behind these interactions remain unclear. Polaris is located about 323 light-years away from Earth, which means the light we see from it today began its journey more than 3 centuries ago. If Polaris were to explode now, we wouldn't witness it until over 300 years later. It's even possible that Polaris has already exploded and we're only yet to see the light from that event. Throughout history, the North Star has been of immense cultural, navigational, and symbolic importance. Its stability and fixed position made it an invaluable guide for ancient explorers. Symbolically, Polaris represented steadiness and direction, remaining resolute amidst the ever-changing sky. For astronomers, Polaris has been a key reference point, aiding in the study of celestial motions and variable stars. As a Psi-8 variable star, its periodic fluctuations in brightness have provided valuable insights into stellar properties and the nature of variable stars. This characteristic has also been crucial in determining cosmic distances and calibrating instruments. These pulsations usually followed a predictable rhythm, making it easy for scientists to anticipate its behavior. However, recently Polaris has deviated from this expected rhythm. This irregularity in its pulsation cycle has intrigued astronomers, prompting closer observation instead of its usual consistent pattern. Polaris has been exhibiting erratic cycles of dimming and brightening. This behavior has raised concerns that the star may be nearing the end of its life. This aligns with behaviors typically seen in stars reaching their final stages, such as the gradual lengthening of Polaris's pulsation cycle, which was once stable. This may be the result of interactions within its stellar system. We've observed An annual increase in the pulsation. Duration by 4.5 seconds, an insignificant amount, yet it holds serious consequences. Some astronomers speculate that gravitational forces between the polar stars could be influencing these fluctuations in its atmosphere directly, affecting the pulsation patterns. However, others are more concerned drawing parallels between Polaris and Bijou, another well-known star in the Orion constellation. Both stars have shown perplexing changes in their luminosity, raising concerns about potential explosion. Stars in their twilight years often exhibit such irregularities before reaching the climax of their life cycles. While NASA has raised alarms about Betelgeuse, similar attention hasn't been formally directed at Polaris. As a SAID star nears the end of its life, it passes through several phases: the main sequence, the red giant phase, and ultimately the supernova explosion. Based on Polaris's irregular pulsations, scientists believe it has entered the stage of helium depletion typical of SEAT stars nearing their demise. These irregularities align with the behavior of stars in their twilight years, but definitive signs of an impending supernova remain unclear. Astronomers are tirelessly investigating these inconsistencies to predict Polaris's future. If Polaris were to go supernova, it could be a spectacular event in our sky, possibly outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance might dramatically alter the shape of familiar constellations, like the Big Dipper or Urim Minor, of which Polaris is a key component. Fortunately, Earth would likely be perfectly safe given its mass and distance from us, while the explosion of Polaris might not be as visually impressive as Betelgeuse's. It could still be visible to the naked eye for an extended period, eclipsing nearby stars. Astronomers and observatories would surely take notice, sparking curiosity in the scientific community and among stargazers. However, the visual impact on Earth's atmosphere or surroundings would likely be less significant than that of a nearby supernova. But what about Polaris itself? What will happen to it after a potential supernova event? Let's clarify one thing: while massive stars typically end their lives in a supernova, this is not the case for Polaris. When a large star explodes in a supernova, its core collapses, triggering an intense shock wave that causes the star to explode violently. But Polaris doesn't have enough mass to experience such a violent end. Instead, when it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This will not result in a supernova, but a calm conclusion as it morphs into a small, incredibly dense stellar remnant. A white dwarf is the remnant of a star that has used up its nuclear fuel and is remarkably dense, about as massive as the Sun but compressed to the size of Earth. When this happens, Polaris will no longer be visible to us on Earth, much like we can no longer see the star in the same way we observe it today. Comparing the expected effects of Polaris's demise with historical supernova events, EV offers valuable insights into stellar evolution and the ultimate fates of stars. For instance, SN 1054 led to the formation of the Crab Nebula, a nebula that continues to expand and emit radiation across various wavelengths, providing astronomers with a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, offered insights into nucleosynthesis and the dynamics of supernova remnants. By studying phenomena such as the form of nebulae, cosmic ray releases, and luminosity changes, astronomers can gain insights into Polaris's potential characteristics. The formation of nebulae, like the Crab Nebula, happens when material is ejected during a supernova explosion, which interacts with surrounding interstellar gas and dust, This enriches the surrounding space with heavy elements and contributes to the cycle of stellar birth and death. Additionally, the shock waves from supernova accelerate high-energy particles, which creates cosmic rays with implications for astrophysical processes and cosmic radiation environments to draw a precise comparison. Scientists evaluate differences in mass composition and the speed of ejected material between Polaris's expected burst and previous supernova. This includes examining the light curve spectra and remnants of these events to predict Polaris's eventual outcome. Despite comprehensive observations, astronomers are still puzzled by the irregularities in Polaris's behavior. Unlocking the reasons behind these fluctuations will help advance our understanding of stellar evolution. Understanding the mechanisms behind Polaris's unusual pulsations requires collaboration across multiple fields and the development of advanced theoretical models and observational tools. The potential disappearance of Polaris as a reference point in the night sky poses serious concerns for astronomical work. Ground-based telescopes and celestial measurements would require calibration, impacting the accuracy of astronomical assessments. Moreover, the loss of Polaris could affect navigation systems and cultural practices reliant on celestial markers, emphasizing the significance of this celestial change. The mysterious behavior of Polaris highlights the importance of monitoring stellar phenomena and fostering collaboration to address the mysteries surrounding star evolution. While the future of Polaris remains uncertain, it serves as a reminder of the constantly changing nature of the universe. Whether Polaris fades away into a white dwarf or explodes dramatically, its role in guiding humanity's exploration of the cosmos will leave an indelible mark as scientists continue to monitor Polaris and refine their models. They aim to better understand stellar evolution and the various paths stars take as they near the end of their life cycles. This research will also improve our ability to predict when such cosmic events as supernova will occur. The study of Polaris anomalies adds a crucial piece to the puzzle, offering new insights into how stars behave as they approach their final stages in the broader context of our solar system. The fate of Polaris shapes how we view the universe. The stars illuminating our night sky are far more fleeting than we often realize. While Polaris may seem like a permanent fixture, in truth, it's just one of countless stars, each on its own journey. Whether Polaris quietly fades into a white dwarf or dramatically explodes, it reflects the life cycle of stars across the cosmos. The story of Polaris mirrors humans' curiosity and quest for knowledge. As we gaze at the stars, we often seek something stable to anchor us in a chaotic world, but the universe is far more dynamic than we can comprehend. Stars like Polaris remind us that even the most constant aspects of our sky are always changing, evolving, and eventually fading. For now, astronomers will continue to gather data and refine their understanding, but we may have to wait years or even centuries before we witness the final moments of Polaris. Regardless, the scientific community will be watching closely the eventual fate of Polaris. Whether it fades quietly or explodes in a brilliant burst will leave an everlasting impression on our understanding of the universe and the forces shaping it. Though we may never see the final moments of the North Star, Polaris's legacy will continue to inspire generations of scientists, stargazers, and dreamers. Whether it fades from view or bursts into light, Polaris has already secured its place in the history of astronomy. It has served as a guide to travelers, a marker of time for ancient civilizations, and a symbol of stability in an ever-changing sky. The future of Polaris remains uncertain, but Its place in our story is unquestionable. As we continue to look to the stars and uncover the mystery of the universe, we can only wonder what new discoveries lie ahead. The cosmos, vast and enigmatic, will continue to reveal its secrets one star at a time.